and welcome everybody. And I think it's good morning, it's good afternoon, it's good evening, and good middle of the night. We've had sign-ups from completely around the world, so I'm very pleased everyone's joined. Not everyone's joined. We got way more sign-ups than we've got participants at the moment, but hopefully people will come along in a minute. What would be really, really useful is if you could actually, I'd like to try and make it look as much like a live event as could be. So if you could keep your cameras on, that would be fantastic. We won't actually include you in the actual webinar presentation itself, but we might do the odd screenshot and things for a bit of social media. So I hope that's okay. For those who don't know me, I'm John Craddock, and I've been working in the identity space for many years now. I was involved with the Microsoft launch of, there's a reminder that's just popped up. Let me get rid of that, and let me make sure that's closed off. Yeah, so I was involved in the launch of on-prem Active Directory. So about the same sort of time, I was working with IBM Federation, and then I got involved in ADFS and did a lot of federated work with that. And then, of course, got heavily involved in Azure AD. And then I was looking at, and I actually started looking at, about the same time Microsoft started work on it, I started looking at decentralized identity and also verifiable credentials, as it was called. And Microsoft have their verifiable credential service, but of course that name changed only a few weeks ago. So now it's Entra Verified ID. So I just love the way Microsoft, you just get used to a name and then they change things. I think the worst thing was, and you probably all suffered this, was the Defender renamed to Defender. You suddenly got to know all the different products, and suddenly they were all new products, but of course they were all the same. Okay, so I'm going to be talking for the next hour or thereabouts about looking at verified IDs, and what I need to do is go to my screen share and kick off on that. And I'm just checking that's coming out, so it is. So that's really good news. So let's, what I'd like to do is just talk a little bit about the way I operate. And the way I operate is to try and take really complicated stuff, really understand it, and then distill the essence of that. And I find it works really well as a consultant, when I'm an architect, if I can actually explain things. But I try and make things as simple as it possibly can, and yet leave the technical depth in there. And I always aim for the Charles Mingus quote of coming up with as much creativity as possible. The other thing I've absolutely loved over the years is actually doing really big presentations at IT forums and tech eds. And I know I recognize a lot of names from people at those different events. And I was thinking about this the other day and thinking, wouldn't it be fun to do a really big presentation of some type again? And I've just seen that they've announced Ignite, and it's sort of partially digital. And they say that a group of people, and I don't know how big the group is, are going to meet up at Redmond by the sound of it. But I got a call the other day from my son. Actually, it was about the Thursday, and he said, "Oh, can I come and see you this weekend?" And I thought, what on earth is this about? He's never asked that short notice to come down and see me. I said, "What's it about?" And he said, "I want to go to the Fatboy Slim concert." And then he said, "Do you want to come too?" And much to my surprise, and I think even more to his surprise, I said yes. So I ended up at the Fatboy Slim concert on Brighton Beach. This guy is the most amazing presenter. Eat, sleep, rave, repeat. And he was going on and on. Eat, sleep, rave, repeat. And I thought, eat, sleep, identity, repeat. No, it doesn't quite work. But I did make it to his video wall. So I almost got on stage with him, but not quite. So I'm going to start off with looking at repetition. Repeat, repeat, repeat. And we've gone through life repeating things when we're involved with digital identity. And if we go back and think about, when we join a school, we will need to be provisioned to the school's identity store. And that might involve at that stage our parents getting involved to prove that they are our parents, and prove where I live, and so on. So we get added to the school store. Now, as Eric, and I'm using the example of Eric, as Eric goes through his school life, he'll pass exams and everything else, and that will be added into the school identity store. And then Eric goes to college or goes to university. And again, he's proofing who he is to that particular college. Again, when he passes his degree, passes his diploma, does his projects, etc., all of that is stored in the identity store. And we know it. As we go through life, we go to work. Again, we're providing the same sort of information to work. And then the next job we go to, the next one, and so on. And then working with financial institutions, we're forever providing proofs of identity and other details. And, if you think about it, is how many times do you need to prove the same thing to yet another organization? The other thing is we are leaving, as we go through life, leaving these silos of our identity. So our diploma or our degree results are siloed in the college identity store. Exams we passed at school are siloed in that school store. And as we go through work, we'll have other bits and pieces siloed. And what we need is a complete paradigm shift. And our paradigm shift would be where we can have an issuer, and an issuer issues a credential about us. And this credential is then bound to our identity. The identity is owned by ourselves. It's not owned by any particular organization. So an issuer binds this credential to our identity, and then we hold that credential. And we could hold credentials from multiple issuers. Now, some of the issuers could be government organizations. Some of them could be the college. Another one might be, for instance, an identity proofing service has actually interviewed us, found out about our academic achievements, put them all together, and issued a credential, which is now bound to our identity, and it's an identity we hold. And then what we do is we can present those credentials as needed to verifiers. Now, verifier is the sort of term that's used, but if you want to use the term relying party, that will work as well. So we can issue them to relying parties. Now, what I want to do is actually do a little demo of onboarding a new employee. So we'll start off, and we've arrived at Woodgrove, and our first name is Matthew. So Matthew is going to be onboarded. Now, what Woodgrove has decided to do is actually to leverage verifiable credentials, and they're going to send Matthew over to their identity proofing service, which happens to be True Identity. So we end up going over to True Identity. And again, they'll be collecting their name, maybe taking a picture. Here we're taking a selfie, uploading it, getting government documents and putting those together, and anything else that you want in that service. So we could actually say that Matthew has to come in for an interview, and we're actually going to interview him and check him out. So whatever needs to be gathered, we can gather. And then what will happen is when Matthew clicks next, it's going to verify all the information, and it's going to build this credential that Matthew can pick up and tie to his identity. So again, we're using the Microsoft Authenticator. We bring that out and we scan this QR code. So we scan the QR code, and what it will do is it will whirl away for a little bit. And then it will offer the chance of picking up this credential using a PIN. Now, what's happened is the identity proofing service has pulled all this data together. They've done the analysis. Maybe they've done a live test, all sorts of bits and pieces. They've got it together, and they're saying that Matthew can pick this up with a PIN. Now, we could have the PIN on the website, but probably we send it via a different method to Matthew. And what he'll do is he'll enter his PIN, or not, the PIN he's been given. And now what he's got this identity or verifiable credential that can prove his identity. And if we look at it, there it is with, and notice the age verification. We didn't put his age in there. We just said he's over 21 because we checked that out. And it means we don't have to have personal identity information in here. And then, the documents that have been scanned, and when this thing was issued. And then very, very importantly, issued by, and we've got the domain name there of the issuer. And notice it says verified. And what I'll do is I will come back to that later on. So if we look at the activity, well, we just got this thing. So let's now return to Woodrow. So we've gone to the identity service that Woodrow uses. Now we're back at Woodrow. And what we're going to do is present that credential to Woodrow. So Woodrow has now produced a QR code, which we can scan. And we're going to scan that QR code. And what it will do is ask us to present this credential. So we're going to share it. And we've now shared it. So we've actually given Woodrow now our identity. And we can see we've got receipts of what we do with our credentials. And then we can go on and go back to Woodrow. And we can then they can provision an account for us. And then we can retrieve a proof that we are a Woodrow employee. So once again, we scan that. And this happens to use a PIN again to pull the data. But what we could do is actually authenticate with Woodrow, provided our account's been provisioned, we could authenticate. And when we authenticate, we can build this credential. But we're just using a PIN in here again. So we do that. Next on there. And now we've got a verified employee credential, or we nearly have. We'd say we want that. Again, we can check its use. But we're going to visit a company that allows Woodrow staff to have a discount. So we're going to go and access the discount, and we're going to verify the credential, which is proof that we are a Woodrow employee. And we'll just scan it again and present the credential. So we're sharing it. And again, if you want, you can check and look at the receipts. So there we are, the initial issuing of it by Woodrow, and then we present it to Prosware. And then we've got our discounts. So that is sort of basically a process of using the verifiable credentials. Who is the custodian of the verifiable credential? The person that owns that wallet. And that wallet is, in this example here, is using the Microsoft Authenticator. So, but if we think about it, isn't this the way that we've always done it? Just imagine Sally's driving along in her sports car, and suddenly a policeman or a police person stops her. And she's probably been speeding or done something wrong. And the police officer wants proof that she is allowed to drive. So what Sally does is she looks in her wallet and brings out the driving license and presents it to the police officer. And what the police officer does is looks at that and says, okay, so you're allowed to drive. Well, it says you're allowed to drive. And I trust that because the photo matches you. It's been issued by the driving license authority, and the sort of envelope it's in has not been tampered with, and probably has a hologram on it and so on. So it accepts that. The beauty of this is that Sally is the custodian of that driving license. She holds it in her wallet and can present it in different situations. So if she goes shopping and she's got a very high value purchase she's doing, maybe the shop wants additional proof of identity so she can present her driving license. They don't care that she can drive, but what they've got is a photo ID of her, and maybe they can verify her address. She can use it to present to a nightclub to prove that she's over 21. So we've got different uses of this verifiable credential that she holds in her wallet. Now, if we look at the components on that, what we've got is a subject, we've got claims, and we've got the issuer who has asserted those claims about the subject, right? And I'm using the sort of analogy of a driving license, but of course this could apply to absolutely everything. So with Woodrow, the subject was, we had our subject, and the true identity vouched for checking the details about that particular subject. And of course, we need a tamper evident envelope. Now, we've got the issuer, we've got the holder, we've got the verifier. If we want to go digital, what we need to do is give everyone a digital identity. And this is where decentralized identifiers come in. And this is where we can give the issuer one did, the holder another did, the verifier another did. And for each did, we generate a private public key pair. The private key never leaves the possession of the entity, and that's really, really important. We need to absolutely secure that private key, and it's only available to us. And then the private key is used to sign messages. Now, if you're not familiar with public-private keys and how they're used for signing, what we have, private key, absolutely, we mustn't lose it. So we securely store that. Using some crypto maths, we can derive a public key, and then we can distribute that public key to anyone. Take the public key, there is no way that you can use any maths at all to go from the public key back to the private key. So you can't go in the other direction. So we can then assemble a message and sign it. We can sign it with our private key. Anyone that receives that message can then validate that message using our public key. And it proves two things, and two things only. It proves the message was created by the owner, or if you want, possessor of the private key, and it proves that the message has not been tampered with. So that's two very, very important proofs. So it arrives, we say, okay, the person that signed this had the private key that corresponds to this public key, and it's not been tampered with. Okay, so we need to make our public key available to absolutely anyone. All right, so if we're going to verify a credential that's passed to us, we're going to have to get hold of the public key. So this is the way that DIDs operate. And what we have is a unique identifier, and then a DID document that goes with that unique identifier. And that DID document contains the actual public key. So down here in the DID document, down here is the public key information. It can also contain other metadata and references, for instance, to a linked domain. Again, I'll come back and exactly what a linked domain is, and also identity hubs. It can have reference to those as well. Okay. And so we've got unique identifier and the DID document. Now, what you do with the DID document, you need to put it somewhere where it can be recovered from. And typically with DID documents, what you did is you actually the idea was, the proposal was that you stored them on some form of decentralized ledger technology, typically a blockchain of some kind. But there are other decentralized ledger technologies available. The idea of decentralized ledger technology is nobody owns the ledger. And an entry onto the ledger becomes immutable when there's enough entries that follow it. So I'm not going to go into the details of blockchain here. That's one method of doing it. Another thing is we could rely on DNS and your domain namespace. So if you've got a DNS name, you could store on your website, right, an actual DID document, obviously all HTTPS protected, but you could store the DID document on your website, so in your domain namespace. Microsoft currently support two methods of storing DID documents. One is it does it on what's called the Identity Overlay Network, or ION. And the idea of ION is that it's a sort of side tree technology. And rather than storing every single DID as a transaction on a blockchain, what it does is it sort of batches DID documents together and then anchors them and on the Bitcoin blockchain. At the moment, it's not doing the anchoring. It's when we store something in ION, it's sitting within the ION network, as in the Identity Overlay Network. It will be anchored into the Bitcoin blockchain at some point. So it actually stores it in an IPFS, or the interplanetary file system. But the anchoring is onto a blockchain. And in this particular case, ION anchors into Bitcoin, or can anchor into Bitcoin. Microsoft also support what's called DIDweb. And with DIDweb, what you do is you publish your actual DID document into your DNS namespace. You stick it on your website, basically. The DID consists of a unique identifier and then the document. We've got unique identifier, which I'll come back to in 1 second, and the document. The document is stored somewhere, okay? And what we've got is this identifier starts off DID. We then have a method. The method is really where the DID document is stored. And then we have a method-specific identifier. So, for instance, the method, we could store it on Bitcoin, in which case the method would be BTCR, all right? And then you'd have a unique identifier that would find it on Bitcoin. It could be on Sovereign, in which case your method is a SOV. Microsoft uses ION, or the Identity Overlay Network. So the method is ION. And they also do DIDweb, and therefore the method here is web, okay? We'll see how those DIDs look in a moment. So if we look at DIDweb, then the DID document is actually stored in entries in the DNS namespace. Literally, think about it. Your DID document is stored on your website. Your website, how do you access it? An HTTPS to your domain name. So, you know, we trust domain verification for all sorts of things. Well, this is just another use of that trust. The format of the DID is always starts DID. So it's DID : web : domain name. So for instance, if my domain name is hr.xtshub.com, the actual DID identifier is DID : web : hr.xtshub.com. And where's the DID document? Well, it's in a subdirectory or a subfolder, which is .well-known, and the actual document itself is did.json. It's possible to specify paths. So what we can do is we could have multiple DID docs published in our space. And to do that, we could actually have different paths where the document's stored. It's also possible to use port numbers as well. Now, there's two sort of flavors of when you're talking about DIDs. you've got the short versus the long form did. So a long form did consists of the unique identifier, so did colon iron, etc., followed by the actual did document. And that is an JSON web token. All right, so the actual did document, it's the did document is in a JSON web token. There's a short form did just consists of the did, the method, and the method specific identifier, and then the did document is resolved appropriately. And the long form did, and the long form did is actually used by the Microsoft Authenticator. It's also is referred to as unanchored did. It's not published. In the future, we'll have universal did resolvers that we can use. So basically, you go to a did resolver, and whatever method you are using, it would find your did document on whatever platform it was sitting. But for the moment, Microsoft have set up a resolver, and at the moment it resolves did iron and it resolves did web. So their resolver at the moment is at beta.discover.did.microsoft.com/1.0/identifiers. All right. So, and what we can do is here you can see that I just add the did web entry in there, and it will get back the did document. I can also add the did iron entry in there. Again, it will bring back the document. There's also, if you want to experiment, there's the Iron Explorer to look with. So, and I'm going to show you this in 1 second. But do you remember when I said to you, look, it says verified, and there was a little verified tick. What it means is it is verified that the did belongs to a particular domain. And the way that we do that is we put a link to the domain inside our did document, and then proof that that did belongs to us is by publishing a did-configuration.json file in our DNS namespace. All right, so we publish that again on our website, and this is not the did document. This is just proof that this did, the one that's being referenced here, belongs to us. And that way we can, in the authenticator, when it says verified, it means that the DNS and the did have been matched up together. And we know that that particular did is owned by that particular DNS domain. So what I'm going to do is look at resolving some dids. And what I'm looking at here is I'm actually inside the organizational settings for Verified ID. And this particular organization is using a decentralized identifier, which is did://web:/hr.xdshub.com. So I'm going to grab that, and I'm going to go and just pop that on there, which is so I can actually use the Microsoft Resolver. I'm also going to pop it in here so I can just show you that this is sitting on my website. So let's start off with the actually using the Resolver. So grab that, and I'll use an incognito window here to do this. So we'll pop that in, and it's resolved the did document. And what you can see is the actual public keys. You can also see the linked domain, and that's very important that we've got the linked domain. Let's just show that that document just exists on my website. So I'm going to drop that in there, and it's brought back exactly what we saw from the resolver. Okay, so my did document, when I'm using did web, is stored on my website effectively. Now, if we go back and actually look at another organization, this organization here is using Iron. So we've got a did sitting here, which begins did : iron. So I'm going to grab that and I'm going to pop that into Notepad. And notice the first part here up to the colon, and is actually up to the colon, is actually the short form did. I'm going to grab that, and then I'm going to actually pop it in over here so I can test the resolver. Okay, and so we're going to go across to the Microsoft resolver, and we'll drop that in, and what we'll find is we get back the did document. This time it has come from iron. So if we look, we've got the link domain in there, and if we go down, we've also got the public keys available to us. All right, and then what I can do is I can use Iron Explorer, and I can come up here, go off to Iron Explorer, and it gives you a sample did. And if we search, what it says is actually not published. So it's actually not published on the Iron network, but it's because it starts Iron and it's a long form did, it will break it up in and display the did document. What I want to do is go and get my did for my organization, and I'm going to add that in here. So we'll go back over, we'll grab my did for my organization. This is the short form did. All right. So to get back the did document, it's going to have to go to the Iron network, and it has. And yes, it's published. And what we can see is we've got link domains, but we've also got in here our public key. And if we check on the link domain, this is masterclass.xdshub.com. So this is the owner of the did. So now the entity generates the private key, and the entity includes the holder. So our user effectively has a did generated for them, which is a private key, and the public key can be published onto either Iron or the actual did web. If we're looking at the actual authenticator, with the authenticator, it uses long form dids. Okay, let's now have a look at our digital driving license again. Now, if any of you are familiar with the mobile driver license, or MDL, there's that's under sort of development. It's a way of having a driving license which is digital, stored on a mobile device. This is nothing to do with that. I'm purely using my driving license as a way of showing how it can be represented as a verifiable credential. And that's all I'm trying to show here. So what we've got is we take our subject, and our subject goes inside an envelope along with the claims that the issuer has put together for that subject. So when we went to True Identity, the issuer, which was True Identity, gathered together lots of claims about the subject. So it then signs that. So that is signed by the issuer. It has the did of our user inside it. All right. Now that's fine. We could present it, but how do we know? Let's say it's still Sally. How do we know it's Sally presenting it? Well, what we can do is wrap that verifiable credential inside another envelope, and inside there we can put the presenter. We can say the presenter is Sally, and then the wallet can digitally sign that. So now everything is basically, we've got the claims that have been asserted by the issuer. In our example, it's the DLA. We then got the subject is built in there. We then said the person presenting this is the same as the subject, which is good, so the driving license got stolen and someone else presented it, you'd reject it. So we can now check that the correct person is presenting their driving license. Now, one of the things, when Sally got stopped by the police officer, she sort of looked and thought, oh yeah, it's a police officer wearing a hat, got a uniform on and everything else. But what we can do, we can go a stage further. When the police officer makes a presentation request asking for a credential to actually be presented, that presentation request can be digitally signed and digitally signed by the verifier. So now we know who we are presenting the credential to. So this gives us a really nice solution. So what are Microsoft doing? They are giving us the Microsoft Entra Verified ID service. They will allow it to be an issuer, a verifier. The holder is going to be the Microsoft Authenticator. And here we can hold the credentials and we can also present the credentials. So remember True Identity, we presented that credential back to Woodrove. And then we took the Woodrove credential and presented it to the store that was going to give us a discount. There's integration with Azure AD, obviously, and there's been lots and lots of changes over time. You have to have an app to maybe issue a credential, an app to actually verify a credential. And at one time, you had to do all the crypto maths. And if you think about it, it's signed by this, signed by that, and you need to verify all of this and create it. It was a lot of work. And a lot of heavyweight crypto math. So what Microsoft have done is they've moved all of that into a verifiable credential service request API. So all we need to do is call that service request API with the right format, and we can get that to actually issue and verify credentials. The VC is defined using a display and rule definition files. And originally, we needed an Azure storage account to hold those files in. Fairly recently, Microsoft, remember it's in preview at the moment, it will go GA in the not too distant future. Microsoft you had to create an Azure storage account to hold the display and rule files. Right now, they're integrated into the Verified ID service, and I'll show you that in 1 second. So if we look at what we've got, the components. So the Verifiable Credential Service Request API, that will build issuance, and it will also build verification for us. We've got the Verifiable Credential Service, and then we've got our own tenant. And in our tenant, what we'll need is a key vault. That's where our signing keys are held for the service. Okay, so we need a key vault, and then we'll need a service principal that will represent the API that we're going to call. And then we'll need a service principal that will actually represent the verifiable credential service. And both of those service principals will need access to Key Vault. So they will need to be provisioned with access to Key Vault itself. Now, we want to call the verifiable credential API. Okay, we want to be able to actually call that particular API. To do that, we're going to need an access token. Right? To get an access token, we're going to have to create and register an app inside our tenant. And we're then going to have to permission that app to the service principal. Right? Now, if you're not familiar with app registration, managing permissions, managing consent, because we have to grant consent as well. What you might like to do is think about coming on my Identity Masterclass. I'll tell you a little bit more about it later, but we go into a phenomenal amount of detail about app registration, OpenID Connect, OAuth 2, etc., etc. And also, the next thing is, having done this, what we'll have is a client ID, which is the application ID, and a secret, which will allow us to provision that into the application. So the application can actually request an access token, which will allow it to authenticate to the actual service API. So that's basically the configuration. In terms of understanding the apps, one of there are good code samples, and if you have a look up on GitHub, that's one place to look. And what I'll do is I will just pop into the I will actually just pop into the chat window in here, pop those in, and those are the samples. And also I've got a blog. The blog is a little bit out of date. I know it's got to be updated, and I'm reluctant to do so until the service goes GA. So no doubt I'll be updating the blog before too long. And the samples are in .NET, Java, Node, or Python, whichever takes your fancy in terms of creating these apps. So that's the issuer and the verifier app. And for some reason, my screen won't move on. Okay, so what I want to do is look at when we set up the organization. This is how we set up the service. So this is the Verified ID service. We need to give an organization name. That's changeable. And we need to choose a key vault. So we create a new key vault if we want to. So we need an Azure subscription to have the key vault. And we can also decide what we're going to use as our trust anchor. Now, notice this thing saying trusted domain. This is the domain where we're going to prove the linkage of our DID to that DNS name, right? And it's also, if we're going to use DID web, it will be where we're going to publish our DID document. So we click on advanced. What we've got is the ability to choose to go for web or iron in terms of the trust anchor that we're going to use. And if we go back to one I did earlier, what we can see is after we've configured, we've got the key vault that's in there. We've got the signing keys, recovery update keys. They're there for future use in the not too distant future. And we see it's generated an iron DID. And that's it. If you want to opt out of the service and clean out all your credentials, you can do that. You can delete the credentials and then reset the service as well. Okay, so it gives you a little bit of an idea of how that gets set up. Next question you can ask yourself is, where do the claims come from? Well, how do we get them how does the issuer get hold of them? Well, we've seen one method, which is statically defining, all right, those credentials. So this is where our identity proofing service has gathered all the information about us, statically defined those claims, and then given a PIN to the user to get those that particular VC. Another method is we could log in. So for instance, in the Woodrow scenario, rather than once we provisioned the account, rather than Matthew having to pick up the employee thing saying he's actually an employee of Woodrow, what he could have done is he could have picked that up rather than using the PIN, picked it up by signing in. That would be another option. If you want, you can get a user to assert claims themselves. So we can actually type in our claims inside the Authenticator app. And it might be that you need a user to prove that they've done some things and they picked up, numbers or codes, and they can put those in themselves. The other thing is we can take from other VCs. So you could take claims out of a couple of different VCs, bring them together, amalgamate them into a new VC. And then the verifier could request the presentation of a single VC or multiple VCs. So the verifier can actually do that. Now, in terms of creating a credential, how do we do it? Well, if you remember, I said there's a display definition and there's a rules definition. This you now do in the UX. And if we look at the display definition, what it is, and a lot of it's fairly obvious, background color, all right? The description that's in there. And Actually, I've just realized I changed the background color on this after I copied that, but never mind, it's not 000. 0000 would be black. And actually, yes, I've changed color as well. So it's not quite right in terms of the color. So ignore the colors, but you can see there's a description, issued by, there's a logo that goes in, a title. And then below the actual card, what you've got is the details that have come out of the VC. So what we've got in there is this has come from the VC, and the claim in the VC was first name, and we're displaying that as James. And then we can decide what label we put on it. So here we're just using the label name. So the actual, in the credential, it was called first name, but when we display it in the authenticator, it's just name. The rules definition is how you get the actual claims into the verifiable credential. And this particular example here is using an ID token hint, and there's various ways. Remember, we can take it, we can statically define them and take it with a pin. We could sign in with an OpenID Connect sign in. We could do that as well, and the other methods that we can use, and that's defined in the rules files. The rule definition and the display definition get combined, and they get combined into what's called a manifest or a contract. And there's a URL where this can be picked up. So the authenticator, when it's told to get a particular credential, what it will do is it will get the manifest, and then it knows how to display the card. And it knows what to do in terms of getting the claims. There's quick starts now. This is fairly new, and I've got a verified employee quick start, which will create me a credential with a display name, a given name, a job title, you know, a surname, etc. And what we can do is change the look and feel of the card in terms of the logo, the text color, and the background color. So that's quite a nice way of starting. So we look at the issuance. This is from the Microsoft sample application. It throws up a web page which is has get credential, verified credential on it. Click on get credential, and then it's running. It's going from index.html to issuer.html, and then it's just displaying a page which says get credential. Click on get credential, and we trigger code flow in issuer.js, which is our actual code. So we're going to get an access token for the API. We cannot call the API without an access token. The next thing we do is assemble an API request, which is basically what we want to do. We're issuing, so we're going to tell the API what actual token, what verifiable credential we want issued, and we'll supply a manifest URL for doing that. We then call the API, and the API comes back with a response, and as part of that response, it can give you back a QR code, or it can give you back a link, and you can generate your own QR code, and then it sits there, the front end web page polling issuer.js to see if there's been a callback, because once you scan the QR code, what will happen is the verifiable credential service request will do a callback saying the QR code has been scanned. So now we can actually say that, and then it's going to be sitting polling again, waiting for the results. So if this was successfully issued and accepted, then we get success and we complete the process. Now, the only difficult bit in your code is knowing what what the body should look like in terms of assembling the API request data, and that looks something like that. I just highlighted. We have the authority, which is who is going to issue this thing. We have the type of the credential, which in this particular case is alumni, and then we have the manifest URL. All right, then we got information about callback, whether we get a QR code, etc. Now, the nice thing about it, what Microsoft have done is they give you the issuance API request body. So you can just cut and paste that into your application. So that's available. Coming soon, and this will look very exciting, users can actually be notified by the Microsoft Authenticator that a credential is ready for them to actually pick up. So you can decide that, you know, a particular group of users needs a particular credential type. You publish it, it gets notified by the Microsoft Authenticator app, or sorry, notified to the Microsoft Authenticator app. The user will see it and then can go through the issuance process, and you don't have to write any code to get that issued. The product group were very kind. You won't see this today, but they were very kind, said I could actually use this in my presentation. So that's great. Thank you. So in terms of the presentation verification request, it's a sort of similar process. So we then build a, using verify.js, we assemble an API request data. Having got the access token, we make the call, and then what it does comes back with the QR code, and then, yes, you've guessed it, it's polling for results. So it gets informed the QR code has been scanned, and what the QR code doing is allowing the authenticator to pick up a presentation request. Having picked it up, it then submits that back to the verifiable credential service, or the credential service request API, and then what will happen is that can then validate the credentials. So there's no heavy work in terms of checking signatures or anything else in your application. So now we're listening again for callback success, and we can display the success of that callback. So that's that. Now, again, if we look at what we need to do in the request body, we need to basically specify the alumni as the type that we want, and then we say who will accept that particular card from. Again, there's help. So number one, there's a published directory of issuers. And you can decide whether you publish something or not. But if you publish a quick start credential, that credential automatically gets published. So I can find my issuer. So here, regatta.com, it's an issuer, published, it's publicly available. And then what I can do is find the verifiable credential. And now if I go through that, so I go verification request, find what I want, and then continue on from there, and I will get the API body to call. So that's, again, a very nice integration and simplifying dealing with verification. There's a management API. So to call the API, you will need an access token. So in exactly the same way as we configured the call to the other service, we need an app registration so we can get an access token to the management API, and then obviously call the API to configure the service. How do we use VCs? This is really open to a lot of thought, and you can start thinking about how you use VCs. Here's our fully verified user who's been maybe true identity, but you know what? We want to know whether the user has a diploma or a degree. So what we can do is we can have the user present a verifiable credential from their college that proves that they actually have this academic achievement. And then we can have our organization's identity access management system, and we could have a user that is fully verified, that presents a credential. What can we do? We can onboard them based on that. We could use it for some sort of verification service before someone's allowed to do a self-service password reset. So we could use it for that. Before we issue them with a temporary access pass so they can update their configuration for their security details. you know, and their FIDO2 keys and their phone and all the rest of it. We can give a temporary access pass. And then what we could do is we could have an app and say, you are only allowed to use this app or other resources if you can present to me the fact that you have done the cybersecurity awareness training. So I could go to a training facilitator, I could get a certificate back and present it. So interoperability, absolutely crucial. And again, what I'll do is I'll drop this into the chat. So just pop that over there. And so have a look at that profile. Also have a look at the appendix of the profile. There's lots of references to the other standards. There's a lot of standards involved. Decentralized Identity Foundation is working. The WWW is working on it as well. And get involved, you know, for your organization. Think about for your industry sector, your vertical. What type of schemas and what type of specs would you want for VCs? Could you get them adopted? So you could take a VC from any issuer and use that. And that would be a very interesting scenario. The other thing I do is I try and encourage people to start conversations in their own organization. And it's not just about IT. It's very much about involving all your departments. Could your legal department use this? Could your marketing department use it? Could your, you know, I don't know, any department, just get everyone involved. You may wonder about backup. Well, that's taken care of as well. So what we've got is the ability to export your credentials, and it does it in an industry standard way. You have to create a 12-word recovery phrase, all right, which is going to be your seed, which will allow you to basically get back in to recover the VCs. And then what you do is you put them in the words, so they're in order. So you need to put in rancid, abstract, Ravy, and of course, these are regenerated each time that you do the backup. And then you can export your credentials, and then to import them, what you'll have to do is supply that recovery phrase to bring them in. So you'll end up with an encrypted file with all your credentials from your wallet in it, plus all the receipts. You know, the receipts that we used to say that we'd got the credential, that we presented the credential, and so on. Coming soon, and again, thank you very much to the product group to allow me to show this. You will find that it is going to integrate with entitlement management. Now, if you're not familiar with entitlement management, it's part of governance, which is part of a P2 license in Azure AD. And I've just got a couple of slides just introducing the idea and concept behind an access package. So in your tenant, you've got lots of resources, right? Applications, groups, and sites. And what you can do is you can gather those together into an access package, right? And if someone is given access to that access package, they'll automatically have access to App 1, App 2, Group 1, and Site 1. And you can have policies that define how users, how guests can gain access to the access package. That's been around for a long time. It's absolutely super. I love access packages. What I really like about access packages is the way they're designed for delegation. So I could have a department which creates a catalog of their resources. It's just the resources that that department uses. And then you could have a project manager who creates access packages for different projects. All right, so, and those, what the resources that go in there are going to be picked from the catalog. And then what we can do is we can assign an access package to someone, or we can allow them to actually ask for the access package. So there's our access package. The thing that you may notice down here is issuer a decentralized ID, and it's also the credential type is true identity. And if we go on, what you'll be asked for is to get access to this access package when we're using my access. So this is how the user gets access to an access package. Goes to my access. It's being asked to present a proof, a particular VC. So they scan the QR code exactly as we've seen. Now they've got access to the access package. That is coming in the not too distant future. If you'd like to be informed by Microsoft, I've got a link to a form you can fill in, and they will let you know when the entitlement management and the integration with the verified ID goes into public preview. I will give you that in 1 second. Now, as we've gone through this, a lot of it also depends on Azure AD authentication, underlying, securing access to apps. And if you want to know more about this, or registering your apps in AD, application protocols, the federated protocols, including OpenID Connect and Auth2, the proxy, and a whole lot more, then if that's of interest to you, then have a look at my Identity Masterclass. The next run of it is actually in October. There are 2 events in October, one in Eastern Standard Time and one in Central European Time. And you know what? When I just saw the announcements of Microsoft Ignite, I thought, oh no, we're going to clash, but we're not. So I'm very pleased to say it doesn't clash with Ignite. It's always got absolutely rave reviews. Have a look at the full spec. It's on learn.xtseminars.co.uk. I'm so confident you'll like it. We do a money back guarantee. I've never had anyone that has been dissatisfied with the event. There are some minor terms and conditions, like you have to turn up, you have to attempt the hands-on labs and things like that. There's an awful lot of hands-on labs. I think you'll find it a really, really useful week. So I'm going to drop the evaluation week. I've spent, I don't know, you might be able to guess, I've spent a phenomenal amount of time actually putting this together. And I've been working on this since 2018, really, not on this slide deck, obviously. And what I'd like to do is just, it's a free event. I know there was about 2 minutes of marketing, but what I'd love you to do is fill in an evaluation and just spend a few minutes of your time to give me feedback. And also, if you want to sign up for the extra VCs, I can put that, and what it will do is it will inform you when entitlement management and VCs or verified ID will go public. That brings us to the end of the webinar. I know I've seen some questions. What I'll do is I will maybe answer them on Twitter. Or if they won't fit on Twitter, I will answer them via LinkedIn, and you'll be able to. So what I'll do is I'll tweet.
Thanks for watching my channel. Subscribe for more free training. You might like to join me for my Identity Masterclass. Hopefully, see you soon.